In this lesson, we shall focus on mathematics, probability for grades 11 and 12. We shall look at mutually exclusive events. We shall also look at independent events, Venn diagrams, and a lot more. And we proceed as follows. Right, question 11. A survey concerning their holiday preferences was done with 180 staff members. The option they could choose from were go to the coast, so they could go to the coast, visit a game park, stay at home, or the total. Determine the probability that the randomly selected staff member is male. Determine the probability that a randomly selected staff member is male. What do you think the answer is to this particular question, Tando?
So it is going to be 83 over 180.
It's going to be exactly 83 out of 180. Well done there, Tando. So the probability of male, because you're able to see that the males are 83, so that then you say the probability of male is actually 83 divided by 180. Right, and so if this is the case, then what is the equivalent decimal of this? So we're going to use our calculator to confirm the decimal equivalent. Right, so now we use our calculator to determine this here. And if we determine our calculator, we have the following. You're going to have exactly 83 divided by 180, and the result is 0.46. 0.46, or you can write it as 46.11%. Right, so it is 0.46. For those who are interested in chemistry, we're going to be doing chemistry tomorrow at this time. Or you can say 46.11%. So this would be the probability of being male. Next question. Determine the probability that a randomly selected staff member does not prefer visiting a game park. What is the probability? Okay, now I'm bringing everybody up to speed here. A survey concerning their holiday preferences was done with 180 staff members. The options they could choose from were go to the coast, visit a game park, stay at home. The results were recorded in the table below. Coast, game park, home, total. Determine the probability that a randomly selected staff member does not prefer visiting a game park. What is the probability that a randomly selected staff member does not prefer visiting a game park? For those who want to do chemistry, we shall be doing chemistry tomorrow at this time. We shall be doing electrochemistry, electrochemical cells, and other sections. But I want to know, what is the probability that a randomly selected staff member does not prefer visiting a game park? What do you think, Tando?
I think the answer will be 118 over 180.
Good. So now the probability that the randomly selected staff member does not prefer visiting a game park, it's going to be the probability of not game park. The probability of not game park is going to be 1 minus the probability of game park. Which is 1 minus. What is the probability of this? The probability of game park, it's going to be exactly 62 divided by 180. Right, and therefore this will be the same as 180 minus 62. And this is exactly the same as what? 118 divided by 180 divided by 2 will give us 59 divided by 90. Using a calculator, For those who are going to be doing chemistry, please, we're going to be actually doing chemistry tomorrow at this time for the chemistry lovers. All right, for the chemistry lovers. In this coming week, we're going to be doing lots of boot camps. Please, I'm planning that pretty much every day we're going to be going live to make sure that we prepare for the September assessments. So it will be very important for people to join in this coming week, as we shall be doing a lot of back-to-back meetings. Right. So now I want us to show this again. So we're going to be doing a lot of back-to-back meetings this coming what? This coming a week. So it's very important that people participate. So this is going to be 0.65 recurring, which is 0.66, or it is 65.56%. So this is 0.65 recurring, which is 0.66, or it is 65.56%. Right, so it is actually exactly 0.66, and it is approximately 65.56%. So that is sort of the probability of not a game park. But again, you see, it's not the only way to do the question. Because if you want to do the probability of not a game park, these are called complementary events. What are complementary events? Right, complementary events refer to the fact that the probability of not A is the probability of is 1 minus the probability of A. A and not A are called complementary events. In the same way, you can say, okay, normally we use the notation like this. We say that the probability of A complement. What is the probability of A complement? It is 1 minus the probability of A. So now these are called A and A complement are called complementary events. So the probability of not game park will be 1 minus the probability of game park. What is the probability of game park? Game park is this one in this two-way table, so that game park is this. The total for game park is 62, so that the probability of game park is 62 out of the total. The total is 180. So that now the probability of not a game park is 1 minus there's 62. 1 minus the probability of game park. Game park is 62 out of 180. And the answer is 118 over 180, which is 59 out of 90, which is 0.66, which is 65.56%. Any question? No question. Who does not understand something here? Everybody understands. Okay. For the chemistry lovers, tomorrow we shall allocate time for chemistry. Please move on. Okay. The next question. A survey concerning their holiday preferences was done with 180 staff members. The options they could choose from were go to the coast. They could go to the coast, or they could visit a game park for the holiday, or they could stay at home on the holiday. The results were recorded in the table below. Are the events being male and staying at home independent events? Motivate your answer with relevant calculations. Okay, right. So in view of these what we call independent events, we start as follows. So we then say, what is the probability of male from the two-way table? The probability of male equals what? Pegalelo, what do you think? The probability of male is equal to what? Ah, okay. Nombuso, what do you think the probability of male is? Nombuso, what do you think the probability of male is? What do you think the probability of... Yes. Are you able to see? the two-way table. What is the total for the male? What is the total for the male? So what is the probability of male, Nombuso? What is the probability of male, Nombuso? Okay. This is the two-way table. All the numbers are here. The male has a total of 83, the female a total of 97, the total is 180. Perelelo, what do you think the probability of male is? Perelelo, what do you think the probability of male is? Is it too difficult? Is it too easy? Nombuso, what do you think the probability of male is? Perelelo, what do you think the probability of male is? Tando, what do you think the probability of male is?
180.
It is actually exactly 83 divided by 180 because the probability of the total for the male is 83, and therefore you are able to see that this is exactly what we're getting here. All right, so we continue. Right now, what is the probability of staying at home? What is the probability of staying at home?
Sir,
Yup.
it is 20 over 180.
20 divided by 180. Well done. So now, what is then the probability of male and home? Perelelo. What is the probability of male and home? Perelelo. What is the probability of male and home? Perelelo. Nombuso. What is
Same.
yes, what is the probability of male and home from this table?
Okay. It will be 13 over 180.
Thank you so much. It will exactly be 13 divided by 180. Right, so this is actually what we have, precisely. Exactly what we have, precisely. And this is approximately 0.07 222. Right, and then you'd have the probability of male times the probability of home. And now we actually going to do that. So let us do the probability of male times the probability of home. What is the probability of male? 83 divided by 180. Of home, 20 divided by 180. Okay, so we're going to do the answer. So which is exactly 83 divided by 180 times 20 divided by 180. Right, so see, this is exactly now the 83 over 180 times 20 out of 180 is 83 over 1620, which is 0, 0,05 1, 2, recurring, etc. And we have the following. Okay. Right. We continue. We continue. So this one is going to be exactly the following. So it's going to be exactly 83 divided by 1620. And as a decimal, it's going to be 0, let us clean this up. It's going to be approximately 0,05 1, 2, 3. So that in the end now, when you do this, you are able to see that the probability of male times the probability of home is actually not equal to the probability of male and home. Right, it's not equal to the probability of male and home because the probability of male and home is 13 out of 180. So 0,07 is not equal to 0,05. That is why, so because are the events being male and staying at home independent events? Motivate your answer with relevant calculations. We see therefore that they are not independent events. Right, so those are not equal to each other and therefore not independent, not independent events, not independent events, not independent events, because this principle does not hold. The left and the right are not equal to each other. We move on to the next question. Now we're looking at a password. A password consists of 5 different digits or 5 different letters of the English alphabet. Each letter may be used only once. How many passwords can be formed if all the letters of the alphabet can be used? What do you think of this particular one? What do you think of this particular one? Okay, so all the letters of the alphabet can be used. Right, so let us take a look and reason together. A password consists of 5 different letters of the English alphabet. So we have a password that has 5 different letters of the English alphabet. Each letter may be used only once. How many passwords can be formed if all the letters of the alphabet can be used? Who wants to try this one? Nombuso, what do you think?
Say.
What do you think? You have 2 minutes. Think about it. I'm not rushing you.
I think so. We are going to use a notation of 5.
Yes. Because you have 5 different what? The password consists 5 different what? Consists of 5 different letters. Are we together? So you're gonna have one letter, one letter, one letter, one letter. So we're gonna have 1, 2, 3, 4, then what? Then 5. Are we together? So there are 5 different letters of the English alphabet. Now, because you are dealing with the English alphabet, how many letters are there in the English alphabet? A, B, C, D, X, Y, Z. How many letters are there? There are 26 letters. Altogether. A, B, C, D, E, F, G, up to Z. There are 26 letters. So now, if you are then saying the password consists of 5 different letters of the English alphabet, then you have 1, 2, 3, 4, 5 letters you're going to put. So the letter to be put here is to be chosen from the 26 letters of the English alphabet, from A, B, C, up to Z. And so there are 26 choices for that. After the letter has been chosen, maybe you choose D. Out of the 26, D is already chosen. You are left with 25 letters, and the letter to be put here can be chosen from 25 letters that are remaining. So you have 25 choices. After that, maybe you choose Z. Out of the 26 letters, then 2 are gone. We're left with 24 letters. So you have 24 choices. Then you remove 3. Okay, then you have 23 letters to choose from, so you have 26 choices. After that, you have 22 choices. Okay. So how many choices are here? 26 times. Right, if you get disconnected, please try to reconnect. Okay, let me see. All right. Okay. 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 Now, okay, we said 26 times 25 times 24 times 23 times 22. So that in the end, you multiply everything here, which is 7, 8, 9, 3, 6, 600. If you use a calculator, 26 times 25 times 24 times 23 times 22, you get 7,893,600. But it's not the only way to actually, deal with this question. There are a couple of other ways to deal with this particular question. All the letters of the alphabet can be used. All the letters of the alphabet can be used. You can also use the formula NPR. NPR would be n factorial divided by n minus r factorial. Right, in this case, it will be, for instance, you can say you are finding the permutation of 26 letters, taking 5 at a time, which is 26 factorial. You divide by 26 minus 5, which is 26 factorial divided by 21 factorial. If you use a calculator to divide 26 factorial by 21 factorial, use a calculator. So we're going to say, for instance, put a fraction here and then say 26 factorial divided by 21 factorial. And it is actually exactly 7,893,600. 7,893,600. So that is the answer. So what is the question here? Where's the question? Where's the question? So now you can then say, because this consists of 5 different letters, you can use the method of the factorials, or you can also use the general counting principle by just putting these blanks and then looking at the choices you have. Or you can use what you call the permutation formula. Right, you can use the permutation formula. What is the permutation formula? The permutation formula is clear that you have the NPR, and NPR is n factorial divided by n minus r factorial. Where's the question? Who has a question? Maybe it's too obvious. It's too easy. Too easy. Very straightforward. Then I'm going to ask you questions. If you don't ask, then I'm going to ask you questions. Then the next question, I'm going to give you some minutes that you try the question, and then we proceed and we move forward. Let's look at that one. Okay, let's look at 12.1.2. Now we're doing this one next. Right, now doing that particular question, we're saying 2.1.2. The password must start with a D and end with an L. Okay. Yeah.
Okay. Yeah. Okay. Yeah. Okay. Yeah.
Nombuso, what do you think? Nombuso, what do you think? Let me see if I still have Nombuso here. Somehow I lost Nombuso. The password must start with a D and end with an L. The password must start with a D and end with an L. How many passwords can be formed? Who knows? The password must start with a D and end with an L. How many passwords can be formed? The password must start with a D and end with an L. How many passwords can be formed? Who knows? Who can try this question? So if the password starts with a D, 1, and then now the password starts with a D but contains 5 different letters. So if you have 1, 2, 3, 4.
Mungu, 。 Zawsze parę bajek, to tylko do banka, że można, nie?
Kyle.
Is
Is it Vutoni? Is it Kyle or Vutoni? Is it Kyle or Vutoni? I think it's Kyle. Right, I'm glad to have Nombuso. I'm glad to have Nombuso. Right, so now the password consists of 5 different letters of the English alphabet. Each letter may be used only once. How many passwords can be formed if the password must start with a D and end with an L? If it starts with a D, it means that D is fixed and L is fixed. So there's one choice here because we're going to have only one letter. There's also one choice there. We're going to have only one letter. But we know that the English alphabet has a total of 26 letters. Right, out of the 26 letters, we've already removed D, we've already removed L, and that means out of the 26, we removed 2 letters, and then we have 24 letters remaining, which is 24. Then after we have chosen, so we're going to have 24 choices for the letter to put here. After we have chosen a given letter, from the A, B, C, D, and then we have X, Y, Z. You choose that. Okay, 2 letters are out. If you choose Z next, then you would have, you'd have 24 letters. If you remove the 2, the D and the L, and you remove 1 more, you would have 23 letters. Okay. Yes, please. Vutoni. Okay, we continue. Right, so now we continue. And out of that, then you'd have, for instance, when you have actually dealt with the 23 letters, you'd have 22 choices to make. So in other words, you look at the English alphabet with 26 letters, you remove D and the L. Okay, so we continue. So now we're going to be here, and I'm going to discuss with you guys, and I know that there are some new guys, Vutoni. There's Vutoni, and there's also, Vutoni. So now with Vutoni, I'm going to teach Vutoni for 5 minutes because Vutoni is new. So Vutoni can join the lessons formally. But we start with the fact that the password must start with a D. All right. So the password must start with a D and end with an L because it starts with a D and ends with what? With an L. So there's one choice for this letter here for the position and another one choice there. So, okay. Now, out of 26, you remove 2 letters. If you remove 2 letters, the D and the L, then you're left with 24 letters. So you have 24 choices. from the 24 letters. After I've put one letter here, we have 23 letters remaining. Maybe you choose Z. We have 23 letters remaining, and you'd have 23 choices. After that, you would have 22 letters remaining, and then you have 22 choices. As a consequence, then, for this particular question, the password must start with a D and end with an L. So you're going to have exactly what? You're going to have exactly 24 times 23 times 22. But you can also put 1 times and if you use a calculator to check this out, "24 times 23 times 22. What's the answer? 12,144. 12,144. $12,144. 12,144. Any question? Good. If you disconnected, please, you try to join again. If you disconnected, please, you try to join in again. Okay, right. So now the password must start with a D and end with an L. If it starts with a D and ends with an L, the question is how many can be formed? Right. The number of passwords that can be formed would be what? Right. The number of passwords that can be formed will be exactly what? There'll be exactly 12,144. And that exactly becomes the answer. That exactly becomes the answer. If you are disconnected, please try to join in again. We move on to the next question, but please make sure you understand this discussion is being recorded, so it means that you shall have the recording available for you at the end of our discussion. We shall have the recording available for you so you can join in. But let us actually right now get started. Oh, let's continue rather. Right, so now in the next question, we are dealing with cars. Cars. 7 cars of different manufacturers, of which 3 are silver. 3 of the cars are silver in color, are to be parked in a straight line. In how many different ways can all the cars be parked? We have 7 cars of different manufacturers, of which 3 are silver, are to be parked in a straight line. In how many different ways can all the cars be parked? Who wants to try this question? If you have 7 cars, the cars are 7 and of different manufacturers, right, of which 3 are silver, are to be parked in a straight line. In how many different ways can all the cars be parked? Nombuso, what do you think? Nombuso, what do you think?
Okay, sir, can you give me some time?
Okay, let me give you some 2 minutes. I'm giving you 2 minutes. Today we're not rushing. Today we are not rushing. We have enough time. I know that you are not even running to school now. It's night. That is why the classes take place late in the evening when you are not running to school. But we're saying 7 cars of different manufacturers, of which 3 are silver, are to be parked in a straight line. In how many different ways can all the cars be parked? Okay, so we continue as follows. Right, Nombuso. Vutoni, I can see you, but my rule is that it's your first time to join us. So since Futoni and Kylie, it's your first time to join us. You need to join the classes officially, you know. But now you see, there are some of the students I know, like Nombuso, Pehelelo, because the Butoni, I've not spoken to your mother or your sister yet. So I want to hear Nombuso, or I want to hear Pehelelo, or I want to hear Tando. Those are the students I want to. Yeah, because you guys, I can see you, but I've not spoken to your guardian yet, your mom, your people, right? But the rest of the people I know Nombuso, I know Pehelelo, I know Tando, right? So now the 7 cars of different manufacturers, of which 3 are silver, and are to be parked in a straight line. In how many different ways can all the cars be parked?
It's not 7 ways, you say.
Okay, that's a good question. That's a good point. Is it not 7 ways? So this one is a very interesting one. And now let us look at these. So the cars are how many? There are 7 cars. So the 7 cars are to be parked. So you need to actually create 7 possible. So 1, 2, 3, 4, 5, 6, 7. So you'd have like 7 possible parking bays of the cars. And then now, because the cars are 7, now you will have this parking spot. The car to be parked here is to be chosen from the 7 cars, but you'll have exactly 7 choices, because you'll have to choose from the 7 cars, and then you park the car here. And then after you've chosen from the 7 cars, you have 6 cars remaining. And when you have the 6 cars remaining, the car to be parked here, you can actually be able to park it, but you'll have 6 choices to make from the 6 cars. After that, you'll have 5 choices to make. And then you'd have 4 choices to make. And then you'd have 3 choices to make. And then you'd have you go to the cars are now, you have 2 cars left. So you decide to drive one of the cars to park it, and then you have 2 choices to make. And then until you have 1 car to park and you have 1 choice to make. And therefore, these cars can be parked in how many ways? They can actually be parked in 7 times 6 times 5 times 4 times 3 times 2 times 1, which is actually 7 factorial ways. Right. So the 7 factorial ways then is equal to what? 7 factorial ways is equal to, so use your computer, please.
Sir,
Yes, please, Nombuso.
sir, can you repeat okay, can you please repeat the sign lay after 7?
Okay, good. I'm going to repeat the sign after 7. Right. So now there are a couple of things that you have, because how many cars? You have 7 cars of different manufacturers, right? Of which 3 are silver, are to be parked in a straight line, right? If you park them in a straight line, then now in how many different ways can all the cars be parked? So the cars are 7. And then you want to park the cars. So you must choose 1 car from the 7 cars. It means that you will have to, you have 7 choices, because if you're supposed to drive the cars, to park them, you need to decide whether to get into the first car, the second car, the third car, because you're 1 person, you need to choose a car to drive at a time. So you'll have 7 choices to make, because you need to choose from the 7 cars. So you have 7 choices to make. And then you take the first car, you choose from the 7, you have 7 choices, and then you park the first one. After that, there are 6 cars remaining. You go there and choose from the 6, you get into the other car, and you have 6 choices, and then you drive that car, you park it, but you'd have had 6 choices to make. you have to decide whether to get into one of the 6 cars, and then you park the car, and then there are 5 cars remaining, and then you have 5 choices. After that, you would have 4 choices. There are 3 cars remaining, you have 3 choices. There are 2 cars remaining, you have 2 choices. There's 1 car remaining, you have 1 choice. So now, as a consequence, you then have 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 7 factorial ways, which is 50, 40. Right, so the 7 factorial ways is what? Is exactly 50, 40. So the question was, in how many different ways can all the cars be parked? The cars can be parked in 7 factorial ways, which is exactly 50, 40 by using a calculator. Where's the question about parking the cars?
Okay. So, okay, thank you so much, sir, by explaining. The thing that I wanted to know is
Yes.
the name of that sign. It's a Victoria.
Which one? This one?
No,
This one?
after 7. After 7,
Oh,
Lapa.
this one. This one.
Yes, yes.
Yeah, it is 7. It's called the 7 factorial.
Victoria. I
Factorial.
thought it's notation.
Okay, yeah, 7
Okay.
factorial is like an exclamation mark like this. But we call it 7 factorial. That's how we read it. We call it 7 factorial. Factorial. Okay, good. We move on to the next question. Next question. The next question is 3 marks. I'm going to give you 3 minutes to try it. We're not running and we're practicing here. 7 cars. We're still on the 7 cars. The 7 cars of different manufacturers, of which 3 of the cars are silver, are to be parked in a straight line. If the 3 silver cars must be parked next to each other, determine in how many different ways the cars can be parked. Now, you need to park the cars. You have 7 different cars. 3 of the 7 cars are silver. But if the 3 silver cars must be parked next to each other, you are told that, you know what? You must park these cars here, Nombuso and Pekalelo and Tando. But now, you are told that the silver cars must be next to each other. So you must make sure that the silver cars are next to each other. Then the others, you can park them anyhow. But the silver ones must be adjacent each other. The question is, right, so, now, Vutoni thinks that it is actually exactly that. No, not correct, Vutoni. I checked your answer. I checked your comment, not correct. Right. Who wants to try the question? The silver cars must be next to each other. Okay. Yeah, that's fine, Vutoni. Okay, I've seen Vutoni's attempt. I'm happy that you're trying. So I'll give you more chance. I'll give you more chance if your mom or your guardian speaks to us. Okay. But now let me see who can answer this question. Tando, what do you think? It's too difficult.
I am not sure.
Okay, that's fine. We don't want to break your brain. You don't want your head to explode because you are thinking too much. That is why there are other people who can think about it. So, let me see. Okay, I can't think that it is 5 factorial times 3 factorial. It is not. But thanks for trying. Right. Pegalelo, what do you think? Pegalelo, what do you think? What's running? Uh-huh. Who is trying?
Okay. Numbers.
Nambuso. Yes, Nambuso. I'm glad that Nambuso is trying.
Okay. Say we
Yep.
know that is okay. We know that we have 7 spaces. Okay, parking.
Yes.
Next.
Yes.
Then we have 3 silver cars that are already parking.
Yes.
Then so it will be 4 factorial.
Okay.
I think so.
Okay, that's fine. That's fine. Remember, we're practicing. And this week, I need full attention because now in the prelims, I want people to perform. I need performance in the prelims, and people cannot sleep this week. Every day at 8 o'clock when you're back from school, you need to join the discussions. Even if you're tired, you need to join the discussions at least for 1 hour. Then you can do your own, your other things, because we cannot afford to have people not performing in the prelims. They are already here. 30th of August, the guys who are in the Gauteng province are writing, and the other provinces also are following suit. Okay, right. So please check the WhatsApp group. Check the WhatsApp group. There is more information there, Vutoni, on the WhatsApp group. There's a poster there. Okay, right. So now, okay, we look at this question. So thanks, Nombuso, for trying, because now we're then saying if the 3 silver cars are parked next to each other. So now what you're going to do here, you're going to do the silver cars. The silver cars are 3 of them. So there's 1, 2, 3. And we're speaking about the silver. We're speaking about the what? The silver. So that for the silver cars, the first car to be parked can be chosen in 3 ways. So you have 3 choices to make for the first car. And then you have 2 choices to make for the next one. And then you have 1 choice to make for the last silver car. After that, then you have the other cars, because there are 7 cars. Then the other cars, you can park them like this. Okay, so the other cars, you can park them just this way. 1, 2, 3, 4. So you have 1, 2, 3, 4, the other cars. Then now you then realize that out of the other cars, the first car can be chosen in 4 ways. So, or you have 4 choices for the first car. And then for the next car, you have 3 choices. And then the car after, you have 2 choices. And then you have 1 choice. 1 choice. So which means that for the silver cars, you'd have actually 3 factorial. For the silver cars, you'll have exactly 3 factorial multiplied by this one's, because it's 3 times 2 times 1 is also called 3 factorial. 4 times 3 times 2 times 1. So it's also called 4 factorial. But now the silver cars can be parked like how? You can put the silver cars in this position, 1, or you can put the silver cars in the position 2, or you can put them in position 3, or you can put them in position 4, or you can put them in position 5. So that the silver cars now, it can be put in actually 5 positions. Either this, that, that. So you multiply by 5. And therefore, we actually are able to get the answer to this. Let's use a calculator. Let's use a calculator.
17,208.
Okay, let us check that one. Let's check that one exactly. Nombuso. We're just checking that one. I'm using a calculator. Why am I getting 720?
So you didn't put
A factorial on the 5.
Oh, yeah.
Yes. Yeah, so the 5 does not have a factorial, right?
Hmm.
Yeah, the 5 does not have the factorial symbol, so that we have 720. So that we have 720. So obviously, this is exactly what we have. Right. So I think that obviously it's very interesting that with only things. I think that obviously your answer was a little bit close. But there was, I think, a small discrepancy there, but very close. Okay, now there are more questions on probabilities that we're going to practice because we want to master probability. We want to excel in the coming prelims. Probability sections are part of this term's work with statistics as well, that we need to master and move on to the next question. Right, the next question is about this Venn diagram. Right, A, B, and C are 3 events. The probabilities of these events or any combination of them occurring is given in the Venn diagram below. So you have this Venn diagram. Right, now you have event A, you have event B, you have event C, and you also have Y there as a probability. If it is given that the probability that at least one of the events will occur is 0.893, calculate the value of Y, the probability that none of the events will occur. What do you think? What do you think? If it is given that the probability that at least one of the events will occur, that probability is 0.893, that at least one of the events will occur. Calculate the value of Y, the probability that none of the events will occur. Okay, thank you so much. So if you get disconnected, please, you need to join in. You get disconnected, please, you need to join in. Now, if it is given that the probability that at least one of the events will occur is 0.893, calculate the value of Y, the probability that none of the events will occur. What is the probability of the value of Y? What is the value of this Y? What is the value of this Y? If it is given that the probability that at least one of the events will occur is 0.893, calculate the value of Y, and Y is the probability that none of the events will occur. What is the value of Y? Okay, I'm giving you 1 minute because it was given 1 mark in the exam. It was given only 1 mark in the exam. Peralelo, what do you think? Okay, Peralelo said the mic is not working. I'm going to forgive you, Peralelo. Tando, what do you think?
I think we take the sample space, which is gonna be 1, then
Yeah.
we subtract with 0.893.
Yeah, well done, well done, well done, well done, well done. So you're gonna realize that what we have here, 1 is the complement of this. So in other words, you'd realize that Y is 1 minus, because the probability that at least one of the events will occur, at least one of the events will occur, is the probability of A or B or C, which is 1 minus. 1 minus. So the probability that at least one will occur, it is either A occurs or B occurs or C occurs, which is 0.893. And therefore, let's use our calculator to get the answer to this one here. Right, now using our answer, using our calculator, we get 1 minus 0.893, and that is what? It's 0.107. 0.107. 0.107. That's the answer. 0.107. 0.107. Where's the question? Where's the question? No question. Right, so we know that Y is actually 0.107. We know that Y is 0.107. We're asking now the question, calculate the value of X, the probability that all three events will occur. Calculate the value of X, the probability that all three events will occur. Who can find the value of X? Who can find the value of X? What is the value of X and how do you calculate the value of X in this question? Who can find the value of X in this question? Who can find the value of X in this question? Okay, so now I know that Vutoni, I've not spoken to your mom yet. Right, I know that I've not spoken to your mom yet. Right, and I would actually obviously always like to give you a chance. Let me see, Parallelo, what do you think? What is the value of X? Parallelo said the mic is not working. Parallelo said the mic is not working. Nombuso, what do you think?
Pastor,
Yes, what is the value of X in this diagram? X is sitting here. X is this one. What is the value of X?
you add everything together,
Yes.
then you will subtract it from the sample space.
Yes, that is correct. So well done there, Tando. Very well done. So to get the value of X, because you are told that the probability that at least one of the events will occur is actually 0.893, right? So which means therefore you will add X plus 0.15 plus 0.05 plus 0.1 plus 0.05 plus 0.2 plus 0.183. Okay, so you have 0.15, 0.05, 0.1, and then we have 0.05, and then you have 0.2, 0.183. And then if you add everything, you'd get the probability that at least one of the events will actually occur, and that will be precisely 0.893, and then you solve for X. And then X is going to be exactly the same as the following, right? And that would be exactly 0.893 minus, you deal with everything that we have added as Tando has said, okay? Right, please, if you get disconnected, please try to rejoin because it can be, I don't know, the network 0.15 plus 0.05 plus 0.1 plus 0.05 plus 0.2 plus 0.183, which is 0.733. 0.733. So now, if you add all these things, it is 0.733. And then now you're going to actually be able to get the value of X. Right, and so to get the value of X, you proceed as follows, which means it is 0.893 minus 0.733, which is 0.16. 0.16. 0.16. So we're to find the value of X, and we found that X is 0.16. Here's a question. Who does not understand how we found X, which is at the intersection of all the three events A, B, and C? Who does not understand how we found X? Who is lost? Where's the question? Who has a question? Who is confused? Okay, I believe people understand. Okay, if you get disconnected, please try to reconnect because it's technology. It's all technology. I wouldn't know why you are disconnected. You know, I wouldn't know why you're disconnected. Okay, now we move on to the next question. Now, A, B, and C are three events. A, B, and C are three events. The probability of these events or any combination of them occurring is given in the Venn diagram below. Determine the probability that at least two of the events will take place. What is the probability that at least two of the events will what? Will take place. You already know that X is what? X is 0, 0,16. We already know that Y is 0, 107. So determine the probability that at least two of the events will take place. Who wants to try that one? What is the probability that at least two of the events will occur? Right. I know of Tony. Good, you want to try. But I'm interested in hearing the students whose guardians have spoken with, like Pehelelo or Nombuso or Tando. Tando just tried now. Nombuso, determine the probability that at least two of the events will take place. Determine the probability that at least two of the events will take place. Nombuso. Determine the probability that at least two of the events. So we'll look at this question here. Determine the probability that at least two of the events will take place. Nombuso. What do you think? Nombuso, what do you think? Okay, let me pick another one. Tando, what do you think? Tando, what do you think? Is it too easy? Okay, we're practicing. It's a practice session and discussion. So it's an open talk. It's not a question of me just giving the answers, but it's a question of you practicing.
Well,
Yes.
I think you add 0,15
Yes.
plus 0,2
Yeah.
and 0,1.
Okay. Yes. So that is what we're getting. So the probability of at least two events. The probability of at least two events is going to be 0,1. So because at least two events, it means that you need to look here. Here it's going to be A and B. But also this 0,1, there's also going to be 0,15. 0,2, 0.16. Okay, so now because this 0.1 is for A and B, and then now you have this 0.2 also, which is for two events. And this one, A and C, it's 0.15. But the X is for example, all the three events. All the three events. So that in the end, you'd actually sum them up. And if you do the probability of at least two events, which is 0.1 plus 0.15 plus 0.2 plus 0.16, which is 0.61. 0.61. So the probability of at least two events is 0.61. The probability of at least two events is 0.61. So this will be the probability of at least two events. The probability of at least two events is 0.61. The probability of at least two events is 0.61. Where's the question? Who does not understand the probability of at least two events? Who doesn't understand the probability of at least two events? Who does not understand the probability of at least two events? So we move on to the next question. The next question is 10.1.3. Now 10.1.3 says, are events B and C independent? Justify your answer. Are events B and C independent? So now we're looking at the events B and C. Are they independent? So we need to first find the probability of B. What is the probability of B? So the probability of B is going to be everything in B. Everything in B, which is 0.1 plus the X. We found the X to be what? 0.16. And this Y is 0.107. Okay. Which is 0.1. And then 0.15. And then I mean, you need to do the following. Probability of B, you add everything in B. So that will actually be 0.1 and then 0.16. Right, 0.1, 0.16, and then you have 0.2. 0.1, 0.16, 0.2, and then you have 0.183. And then now you'll be able to get the probability of B. We're going to use a calculator to add those up. And then now you are finding the probability of C. What is the probability of C? It is 0.2, 0.05, 0.15. So this is 0.2, 0.05, 0.15. And then you also add 0.16. Let's check. So you have 0.2 for probability of C, everything in C. It's going to be 0.2, 0.05, then 0.15, and then you have 0.16. So right now you're able to find the probability of C. Okay. And then also we'll continue to find here the probability. You can write it down here. The probability of B and C. So now if you continue here and find the probability of B and C, right? So the probability of B and C, you'd have to look at what is common in B and C, and clearly we're able to see in B and C, you'd have 0.16 in B and C, you'd have these two here, and then also you'd have 0.2. But this one is easy. 0.16, 0.2 is 0.36. Right, then you'd have to do the next one. 0.1 plus 0.16 plus 0.2 plus 0.183 is equal to, which is 0.643. 0.643. Then you're going to do the next one. Then you're going to do right now the probability of C. And the probability of C is, we start here 0.2. And then we add 0.05. And then we add 0.15. And then we add 0.16. Right, and the answer to that is 0.56. It is actually exactly 0.56. So 0.56 is the probability of C. So right now, if you compare, right, you need to actually check the probability. So the probability of B, so you can write here, right, you can come here and write the probability of B times the probability of C. Right, so the probability of B is 0.643 multiplied by the probability of C, which is 0.56. And then we multiply these two things. Right, so let us check. If you multiply the probability of B times the probability of C, the probability of B times the probability of C, which is 0.643 times 0.56. And what is the answer? It's 0.36. 0.36. 0.36. So that in the end, then, the probability of B times the probability of C is equal to, what is the probability of B? 0.643, 0.56. And then what is the probability of B and C? Right. So we're able to see the probability of B times C. So yeah, we can just write like this. You can just write as follows. So the probability of B times the probability of C 0.36, and then the probability of B and C is 0.36. So that this is the probability of B and C. Okay, so the probability of B times the probability of C is the probability of B and C, because it's 0.36, the other one is also 0.36. So indeed, these probabilities and this probability formula holds true, right? And the conclusion, therefore, is that B and C are independent. B and C are independent. Where's the question? Because are events B and C independent? Yes. B and C are independent events because the probability of B times the probability of C is actually equal to the probability of B and C, because they are both 0.36, 0.36. Where's the question? Where's the question? Who has a question? Who has a question? Who has a question? In the absence of a question, we move on to the next point. We move on to the next point. Right, the next point is actually 10.1.3. Which we have done. Next, let's check the next question. Okay, the next question is about a code A 4-digit code is required to open a combination lock. The code must be even numbered and may not contain the digits 0 or 1. Digits may not be repeated. How many possible 4-digit combinations are there to open the lock? Right. Who wants to try this one? How many possible 4-digit combinations are there to open the lock? A 4-digit code is required to open a combination lock. You want to open a combination lock. The code must be even numbered. So this code must be an even number and may not contain the digits 0 or 1. So 0 or 1 are out. Digits may not be repeated. How many possible 4-digit combinations are there to open the lock? Right, want to try this one? Nombuso, what do you think? Nombuso, what do you think? 2 minutes to try this one. If Nombuso is still there, I believe.
Yes, sir, I'm still here.
Okay, good. Please try it. How many possible 4-digit combinations are there to open the lock?
I think it's 7. I mean, sorry, it's 4 factorial.
You think it is 4 factorial? Okay, let us check if it is that. So, but now, because you are dealing with a 4-digit code, so you need to look at how many digits are there altogether in the world. How many digits? The digits that exist in the world is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now if we then say how many possible 4-digit combinations are there to open the lock? Now the 4-digit code is required to open a combination lock. The code must be even numbered and may not contain the digits 0 or 1. Digits may not be repeated. How many possible 4-digit combinations are there to open the lock? Right, so because now you are dealing with the 4-digit combinations. 4-digit what? Combinations. Right, so dealing with 4-digit combinations, we have exactly the following. So, but 0 or 1 are out, so you must remove 0 or 1. So in other words, but now you are dealing with a 4-digit code. Right, dealing with a 4-digit code, you would have therefore this. Right, you'd have exactly this. So that is 1, 2, 3, 4. You are dealing with a 4-digit code. Dealing with a 4-digit code, you have that 0 or 1 are out of the picture. Okay, right. So now, if 0 or 1 are out of the picture, what do you then have? But also, the code must be even numbered. If the code must be even numbered, it means that the last digit must be an even number. If the last digit must be an even number, it can be what? It can be a 2, it can be a 4, it can be a 6, or it can be an 8. And these are 2 4 digits. These are exactly what? 2 4 digits. Okay, now, and then if there are 4 digits, you then realize that after you have chosen the digit, maybe you chose 4, so 4 is out. But also 0 and 1 are out. You are left with 1, 2, 3, 4, 5, 6, 7 digits. Then these digits can, so in other words, you have 7 choices to make. After this one has been chosen, maybe you chose 8, then you have 1, 2, 3, 4, 5, 6. So you have 6 choices to make. Right. So after that, maybe you chose 7. You'd have 1, 2, 3, 4, 5. You'll have 5 choices. 5 choices to make. In the end, you'd have 7 by 6, by 5, by 4, 7 by 6 by 5, 7 by 6 by 5 by 4, which is actually exactly 840. If you use a calculator, 840. Right. So who has a question? Can use a calculator to confirm our answer. Right. You can use a calculator to confirm our answer. So in other words, if you then come here and then say you're going to have 7 times 6 times 5 times 4, 7 times 6 times 5 times 4. This is actually 840. 840. So in other words, how many possible 4-digit combinations are there to open the lock? There are 840 possible 4-digit combinations to open the lock. Where's the question? Who does not understand something here? Who is confused? Who is confused? Okay, this is all about probabilities. It's about probability calculations. So you need to pause to think. If you don't understand some of the things, this video is gonna be made available after 10 o'clock tonight, so you can start watching. I'm gonna make this available to the students. I'm gonna make this available to Tando. I'm gonna make this available to Pegelelo. I'm gonna make this available to Nombuso. Those are the students that I know. And then I'm going to make this available to those particular students there, Nombuso, Pegelelo, and Tando. Right. But now, guys, I repeat this solution. I'm going to repeat this one to make sure you understand, because I think that some of you guys did not understand. Right. So we're dealing with a 4-digit code, and a 4-digit code is required to open a combination lock. So there is a lock. This lock requires you to put in a 4-digit code, but the code must be even numbered and may not contain the digits 0 or 1. So now we need to look at, because we're speaking about a 4-digit code, we have to look at all the digits in the world, all the numbers in the world. They've been formed using these digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And then now, but there is a rule here that 0 or 1, the even numbered and may not contain the digits 0 or 1. So 0 or 1 must be out. So you must remove 0 or 1. The digits may not be repeated. You know that the digits may not be what? So there are no repetitions. A digit is used only once in the code. How many possible 4-digit combinations are there to open the lock? Now we need to count the possible 4-digit combinations that are there to what? To open the lock. And we proceed then as follows. So what you do here, what you do is you consider this actually, and you perform a calculation, but you perform a little split. What little split do you do? So you then say, if this digit must be even numbered, an even number like 72, how do you know that 72 is an even number? Because you look at the last digit. The last digit must be an even number. If you have 136, it's an even number because the last number is divisible by 2. So it's an even number. So in other words, if now you want to form this even numbered the code must be even numbered. It means that the last digit itself must be such that what? The last digit itself must be such that it must contain an even number. How many even numbers are there? 1, 2, 3, 4. 1, 2, 3, 4. So you must have 4 of those digits. 4 possible choices, right? So you'd have 4 choices to make, right? So in other words, if the code must be an even number, it can end in a 2, or it can end, the last digit can be a 4, or the last digit can be a 6, or the last digit can be an 8. So you have 4 choices. And after that, you take one of the digits you put here. But you realize that if out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, out of the 10 digits, you already removed 2, which was 0 and 1, and that left you with what? That left with a total of 8. And out of the 8 digits, you remove 1, which is the even number you have put here. That leaves you with what? With 7 digits, and means that you have 7 choices of the digits to put here, right? So when you have 7 choices, after you have put a digit here, you would have 6 choices, and they reduce by 1, right? And then in the end, then you have 7 by 6 by 5 by 4, which is the total of 840. This discussion is recorded for control and quality purposes. You can always watch it even tomorrow. You can watch this recording in the morning. You can practice probability with it until you master this particular section. It can be a little bit tricky, but I trust you that you can actually be able to learn from this. We move on to the next question. The next question is 10.2.2. It is still on the 4-digit codes, and it's tricky, right? A 4-digit code is required to open a combination lock. So you must form this code. It is required to actually open what you call a combination lock. The code must be even numbered and may not contain the digits 0 or 1. Right, may not contain the digits 0, 1. Digits may not be repeated. Right, calculate the probability that you will open the lock at first attempt. If it is given that the code is greater than 5,000, they tell you that, okay, you need to guess the code. Guess the code to open the lock. But they're giving you a hint. They're saying the code is greater than 5,000. And the third digit is what? Is 2. Calculate the probability that you'll open the lock at first attempt. Right, so it's 5 marks, this one. It's 5 marks. I'm giving you 2 minutes. I'm giving you 2 minutes. Okay, if you look at this, you need to think about the fact that you are dealing with the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So you are dealing with these digits here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You are dealing with these digits here. The question we're asking you, calculate the probability that you'll open the lock at first attempt if it is given that the code is greater than what? Is greater than 5,000. And the third digit is 2. Who wants to try this one? 2 minutes. Think about it. Probability. Who wants to try this one? 2 minutes. Try it. 2 minutes. Try it. Right. 2 minutes. Try it. Right. Who wants to try this question? Right. Who wants to try it? I'm giving you 2 minutes to try. I'm giving you 2 minutes to try. I'm giving you 2 minutes to try. Right, want to try? Everybody's sleeping. Okay, people are tired. Okay, never mind. So I'm gonna give you the answer. So you're gonna start. You're gonna start with. You're gonna start with a 5, a 7, or a 9. Or start with 6. Start with 8. So now you're gonna start like this. 2, 4. You start with okay. You need to start with a 5 or a 4, a 5, a 7, or a 9. Okay, we start with those. But look, the 0 and 1 from the digits are out of the picture. And then now you need to start with a 5, a 7, or a 9. So in other words, if you start with those, you would actually starting with some of the numbers, but you bear in mind that if you start with 5, 7, or 9, you would have 3 choices. Or, okay, this is the plus, this is the plus. It sort of forms a separation. Now you have 1, 2, 3, 4 digit code, 1, 2, 3, 4 digit code, 1, 2, 3, 4 digit code. So you can start with 5, 7, or 9, or you can start with a 6. So you have one choice, or you can start with an 8. So you have one choice, but the third digit is 2. The third digit is 2, meaning 1, 2, 3. So there's one choice for this digit. There's one choice for this digit. There's one choice for that digit because the third digit is 2. So there's only one choice. Now, if you start with 5, 7, or 9, then it means that the last digit, it's going to be what? Right. You know that the last digit, it's going to be such that in the end, if you start with 5, 7, or 9, 5, 7, or 9, and the last digit must be an even number. Right. If you start with 5, 7, or 9, you have actually, for instance, 1, 2, 3 choices. After that, after you have had these particular 3 choices, then the even numbers would be 1, 2. Okay, so 2 is out because it's fixed. So you'd have 1, 2, 3. So you'd have 3 choices for this. Okay, and then if you have 3 choices for that, right? Um. Okay, yeah, we continue, please. Right. So, okay. If you check, okay, we're right back. So you'd have like 3 of the even ones. Now, let us count together. So now you'd have, for instance, 5, 7, or 9, 3 choices, and then 2 is out because it is in the third position. Then you have 1, 2, 3 even numbers to be in the front so that you have an even code. And then now you'd have, for instance, so you'd have, if you choose 6, and then you'd have chosen 5. Then you're left with 1, 2, 3, 4, 5. So you'd have 5 choices for this particular digit there. Next, if you start with a 6, because the digit must be greater than 5,000. Greater than 5,000 means that you can start with a 5, 7, or 9, or you can start with a 6 because the number starting with 6, like with 6, 3 zeros, it will be like 6,000. All right, but we have one choice there. So if you start with 6, you start with 6. Let us check this one here. So you remove these things. Okay, so let's do this. You start with a 6, and then you'd have a 6 here. And then the 2 is fixed. So 2 is fixed, and the 6 is taken. And then now, after that, you would have exactly what? So you'd have to deal with the even numbers in the front. So there will have to be 1, 2. So you'd have 2 choices for the even numbers in the front, and then you can choose one of them. After that, you'd have 1, 2, 3, 4, 5. Then you're going to have 5 choices, right? So in the same way, you decide, okay, you do this. You say the 2 is out because it is in the third position, but also you start with an 8. So the 8 is out. If then the digit is to be even, then the last digit, you'd have 2 choices for the last one. Okay, good. You'd have 2 choices for that. And now if you choose 4, then you're gonna have 1, 2, 3, 4, 5. You'd have 5 choices for this one. And therefore, in the same way, then you're gonna have what? This is gonna be exactly, it's gonna be exactly what? It's gonna be exactly the following. So it's gonna be 3 times 5 times 1 times 3 plus 1 by 5 by 1 by 2, 1 by 5 by 1 by 2, and then you have 3 by 5 by 3, which is 45, plus 1 by 5 by 1 by 2, which is 10, plus 5 by 2, which is 10. And therefore, this is 65. So right now, at this point, you therefore have the probability, right? So you continue to do the probability calculation now. So you'd have the probability that, for example, right, so the probability is going to be what? The probability that is required here is going to be exactly 65 divided by the total. The total we got here is actually 840, which is the total for how many possible 4-digit combinations are there to open the lock. The possible 4-digit combinations are 840. So which is the total. So you put here 840. Right. If you have 840, you divide 65 by 840. And if you use a calculator to do that one, and you divide 65 by 840, right? So you would actually do this and say 65 divided by 840, right? Which is 13 divided by 168. 13 divided by 168, which is exactly 0.08. 0.08. So in other words, this one here is equal to, is exactly equal to 13 divided by 168, which is approximately 0.08. Approximately 0.08. What's the question about the probability that you'll open the lock at first attempt if it is given that the code is greater than 5,000? It is greater than 5,000, and the third digit is a 2. It's 5 marks. They gave it 5 marks because it was a lot of work. It was a lot of work and a lot of reasoning. So, but this discussion is being recorded, guys. Because it's being recorded, I'm going to send you the recording after 10 tonight. And you can watch it even tomorrow. But also, we're going deeper this week. Every single night. It's going to be math, science until you learn the math and the science. But until you master all these things, until you master the physics, the chemistry, and everything that comes with it, we move forward. Now, let us look at this particular question here. Let us look at this particular question here. This particular question is about, a survey. A survey was conducted amongst 100 boys and 60 girls to determine how many of them watched TV in the period during which examinations were written. So there are some of the students that were watching TV when the examinations were written. Their responses are shown in the partially completed table below. There are those who watched TV during examinations. There are those who did not watch TV during examinations. And some of the students were male, some of the students were female, and the totals were there. Now, this is exactly what we have. So we need to calculate the values of A and B. You need to calculate the values of what? You need to calculate the values of A and B. So to calculate the values of A and B, you would have the following. For 2 marks, who can tell us the value of A here? Who can tell us the value of A? For 2 marks, who knows the value of A? Who knows the
Sir?
value of A for 2 marks? Nombuso.
Sir?
Yes, who am I talking to? Is it Nombuso or Pekhalelo?
Hello.
Okay, yes. What do you think is the value of A, Pekhalelo? I'm happy to speak to you because I think it was difficult for you to connect today.
Yes.
What do you think the value of
Um,
A is? Are you
we
able to
say
see this table?
yes, I am.
Okay. What do you think the value of A is?
Aren't we going to say 160 minus 80 to get A?
Okay, that's fine. So now to get the value of A, you need to know that A plus this number is equal to 32. A plus this number is equal to 32 because this row is for the totals, right? So A plus this number is equal to 32. So now, in other words, you're going to say A plus, right? You're going to say A plus 12 is equal to 32. A plus 12 is equal to 32, which means A is 32 minus 12. What is 32 minus 12? It's a 20. So which means that here we are shown that A is equal to 20. Okay, let me see. Okay, that's fine. Thank you so much. Thank you so much for actually being in a position to observe your mistake. All right. I want, as said already, guys, the exams are coming, and my fear is people do not practice enough. And this week, I'm gonna be inviting you more frequently in the evenings for 8, but I'm gonna be letting you know early in the day, earlier on, early, in the morning hours, so that you can prepare yourself and know that tonight we have chemistry, we have math, we have physics, so that you can actually join these lessons. We need good marks in these prelims. We don't need low marks, please. We cannot afford to struggle in the prelims. Okay, we found A. What is B now? So if we found that here A is 20, now B is here, what is the value of B? Nombuso, what do you think the value of B is? Nombuso, what do you think the value of B is?
Okay, the value of B,
Are you able to see that B is this one, right?
yes.
What do you think the value of B is, and how do you get it?
Okay,
Sir?
I think it will be 128.
Yes. How do you get it?
I add up I add up 80 plus 48.
Well done. Yeah, Peralero wanted to give the answer, right? Peralero, you wanted to give the answer. Okay, so we add 80 and 48, and 8 and 48 gives us 128, right? I know. Yeah, so we got that B is 128. I think Pekale wanted to also give the answer there. Okay, so that's fine. I'm happy that you're able to get this one. And then let us move to the next question. I want to see what you're going to do. I want to see what you're going to do. Okay, we got A is 20 and B is 128. That's fine. So we got that A is 20. We got that B is 128. Calculate the values of A and B. Are the events being a male and okay, we are right back. Are the events being a male and did not watch TV during examinations mutually exclusive? Give a reason for your answer. Are the events being a male and did not watch TV during examinations mutually exclusive? Give a reason for your answer. Who wants to try that one? What are you supposed to do here? What do you think? The event being a male and yeah, the event being a male and did not watch TV during examinations. Mutually exclusive. Give a reason for your answer. Who wants to try that one? Pegelelo. I know that Tando attempted most of the questions, so I'm trying to give these guys a chance to try something because Pegelelo was like struggling to connect today. So, are the events being male and did not watch TV during examinations, mutually exclusive or not? Give a reason for your answer. Who wants to try? Who wants to try? Who wants to try?
Sir,
Yes, Tando. What do you think, Tando?
for events to be mutually exclusive, the
Yes.
probability of A and B should be equal to 0.
Yeah, the probability of A and B should be equal to 0 for them to be mutually exclusive. Thanks a lot, Tando. So which means that the probability of male and not watching TV and not watching TV. What is this probability? The probability of male and not watching TV. What is this probability? Who can find it? What is the probability of male and not watching TV? What is it in this question? Who can find it? What is the probability of male and not watching TV? What is it in this particular question? The probability of male and not watching TV. Nombuso, what is the probability of male and not watching TV? What do you think the answer is?
Okay, so I think it will be 20 over 100.
Well done. So it will be 20 divided by the total. So because male and did not watch TV is 20, male and did not watch TV is 20, but the total is what? Is 160. So always put the total for the probabilities. So that's going to be exactly 20 over 160. But the probability of male and not watching TV is that which is not equal to 0. Right. So are the events male and did not watch TV during examinations mutually exclusive? No. The answer is no. Why? Because this probability, why? Because this probability is not equal to 0. The probability of male and not watching TV is not equal to 0. Let us look at the next question.
So,
Yes, please.
may I ask
Yes, please.
why we do not divide by 100?
Okay, why don't we divide by 100? Okay, Okay, because we look at the total. Because I understand that you're saying there are 100 boys, right? Because now you are seeing that there are 100 boys and there are 60 girls. But for us to get the probability, we must divide by the total of everything.
Oh, okay.
Yeah, and the total of
Okay.
everything. We always use the total of everything. Always, always, always. So for the probability, always use the total of everything. Okay, right. Now we move on to the next question. Move on to the next question. Okay, if you look at this one, if a learner who participated in this survey is chosen at random, okay, we know that A is 20. Okay, I know I can see the time. We're going to finish. But I want to finish this question first. If a learner who participated in this survey is chosen at random, what is the probability that the learner watched TV in the period during which the examinations were written? If a learner who participated in this survey is chosen at random, we still are having 100 boys and 60 girls. And there are those who watched TV during examinations. Some were watching TV during examinations, but some did not watch TV during examinations. If a learner who participated in this survey is chosen at random, what is the probability that a learner watched TV in the period during which the examinations were written? What is the probability? Right. What is the probability that the learner watched TV in the period during which the examinations were written? 2 marks. I'm giving you 2 minutes. So, what is the probability of watching TV? We want the probability of watching TV. What is the probability of watching TV? What do you think? Anyone? What is the probability of watching TV?
Okay.
Because
So
now
for
they're saying,
both,
yeah, okay, yes, what do you think?
okay, I think it's 128 over 16.
Well done, excellent stuff. So the probability of watching TV during examinations is 128 divided by the total of everything. The total of everything is 160. Right, it's 160. And that is the answer. So if you simplify this one, you get actually exactly 4 out of 5. And 4 out of 5 is approximately 0.8, or you can say it is actually 80%. So this, if a learner who participated in this survey is chosen at random, what is in this survey, what is the probability that the learner watched TV in the period during which the examinations were written? So the probability is going to be what? It's going to be exactly 128 of watching TV over the total of 160, and it is actually 0.8, which is exactly 80%. Okay, good. Very well done. Okay, this is our last question. I can see that we are beyond the time, but I'm just finishing this question. So we continue to do the next question, which is 11.3.2. Right. It is not, what is the, if a learner who participated in this survey is chosen at random, so we are still looking at the fact that our A is 20 and our B is 128. It is not, okay, yeah, they're saying, if a learner, remember, a survey was conducted amongst 100 boys and 60 girls. We're still dealing with 100 boys and 60 girls. If a learner who participated in this survey is chosen at random, what is the probability that the learner is not a male and did not watch TV in the period during the examinations? 2 marks. The learner is not a male, but also this learner did not watch TV. What is this probability? Okay, so what is the answer to this one?
Sir,
Yes.
It is 12 over 160.
Well done. It is exactly 12 over 160 because the probability that is not male. So, in other words, it is the probability that a planet that is not male is female and not watching TV. Right, is female and not watching TV. And what is the answer? Okay, if it's not male, is female and not watching TV. So, what is the probability of female and not watching TV? It's 12. So, you have 12 divided by the total of everything, which is 160. And if you divide this one, it's actually 3 divided by 40, and it is actually 0,075, and this is actually 7.5%. It is 7.5%. This is the probability that it is not male or is not a male. It's not a male, meaning it's a female and it did not watch TV. Female and did not watch TV is 12 out of 160. I think I must thank you guys for joining us. It was awesome having this discussion. Right. And I must give you a little homework. Something you did not. Okay, here is your home activity. Obviously, I know that you might not have a chance to copy down, but I'm gonna, after 10 tonight, I'm gonna send this recording to you and you can watch this and you can do the homework. The homework is question 12. The digits 1 to 7 are used to create a 4-digit code to enter a locked room. So there's a room that is locked and there's a 4-digit code that you need to create, right? How many different codes are possible if the digits may not be repeated and the code must be an even number bigger than 5,000? We repeat the question. It is question 12. The digits 1 to 7 are used to create a 4-digit code to enter a locked room. So remember, you are using the digits 1 to 7 as much as we used the digits 0 to 9 before, but the examiner is saying, hang on, please, guys, use the digits 1 to 7 are used to create a 4-digit code to enter a locked room. The room is locked, but you need to create a 4-digit code to enter this room. How many different codes are possible if the digits may not be repeated and the code must be an even number bigger than 5,000? And the marks are 5 for that question. It is your home activity. I can see that we have gone beyond 10 p.m. and now sometimes we shall go up to 11 p.m. at night. We shall go until 12 midnight. Those days are coming. Okay, and it's very important that you people attend regularly because we need to make a difference. We need to see different marks, but we can't see the different marks if we remain lazy and we fold our arms and we do not take things very seriously. This is injury time. It is the 11th hour and we cannot falter. For the guys who are in grade 11, Tando and Pehelelo, you guys, the matric is waiting for you, and these things are there in both grade 11 and both in matric. So you need to understand them, but also you need to get good marks at grade 11. How are you going to apply to university with grade 11 marks that are poor? How are they going to take you at university? So you need to think about these things. Because if you are lazy at grade 11, then your marks are going to be affected. How are you going to apply to be at university? How are you going to become a medical doctor? How are you going to become an engineer? You need to think about these things. Your grade 11 marks are very important because those are the ones you're going to use to apply to university. But now, if you are just folding your arms like that, then what is going to happen to your future? Then how are you going to apply at university? They're not going to take you. Then what is going to happen to you? Because now you are doing matric 1, you grade 11s, and these things are there at both matric and grade 11. I'm just saying, guys, please wake up and please pull up your socks. And now, even tomorrow we're here at 8 o'clock at night. So up to 10. And we shall be doing sometimes up to 12 midnight and practicing and discussing and solving problems and you guys trying and being corrected where you went wrong. We want to see your mistakes. And now it is very, very important. Nombuso, the trials are here for you. The trials are here for you. For Nombuso, the trials are here. They on the 30th of August, you are writing paper 1. And paper 1 is having these things. So now I want to see a difference, please. We cannot falter. Okay, right. Thanks so much for obviously trying there. We cannot falter there. So Nombuso, we need to make a difference. We need to see a difference, but we need to change the tune. We cannot sing the same hymn. We need to now dance differently. We need to make sure that we are actually on air, and we attend, and we are online, and we do these things, and we practice. Most of these discussions are going to be open discussions where we talk, we discuss, you try the questions, you are corrected. That is going to show you where you made mistakes so that you can avoid the mistakes. It is my wish, it is my dream that from this coming week, every day at 8 o'clock at night, during the day you can do your things, but at 8 o'clock at night you are on air. We do 8 o'clock until 10, or we do 8 o'clock until midnight every day. If it is not mathematics, it is physics, it is chemistry, until you guys learn. Because I want you to master the syllabus. I want you to know everything from A to Z. But how are you going to know these things from A to Z if you don't attend all the time? And because the trials are here for Nombuso, 30th of August, the prelims, the trial exams are here, that are going to be coming from the provincial office. They're not even sent by your school. And they're going to be very tough, those prelims, because those prelims are like the final exam. They've all the topics. So you can't afford to falter in the trials. And so the only way is for us to make sure that tomorrow we're here at night, at 8 o'clock. If need be, we're going to do 8 to 12 midnight. Weekends 8 to 12 midnight. During the week we can do 8 to 10, but on weekends we do 4 hours, 8 to 12 midnight, to make sure that we have a chance to do mathematics and also science at night, both. Okay, I must thank you guys for joining us, but please, we are back again tomorrow at 8 o'clock. It is my wish that we improve the marks. We improve the marks, but the marks cannot improve it if we do things the same way. We must make sure that we practice more. But one way to practice, these are past exam questions. These are not questions from me. These are past exam questions. So if you master these questions, then it means that you'll pass the exam, because these are from the examiners themselves. Right. I must thank you guys for joining us. This is your home activity. You're gonna try it, and we shall meet tomorrow. Right. From us, take care and good night. Goodbye, guys. Right. Goodbye.